of the integration of nervous neural activities. Without reflex, most of our day-to-day motor activities will be lost. আমরা যে প্রতিদিন যে আহ, জেগে থাকে, when we are awake, uh, and in the daytime when we are performing many different types of motor functions, activities, a lot of these activities will be lost if reflexes are lost. What is the reflex? Reflex or reflex action is defined as involuntary motor response to a sensory stimulus. এখানে কয়েকটা স্পেসিফিক কিওয়ার্ড আছে। একটা হচ্ছে involuntary response. A reflex is a motor response. A reflex is a motor activity. Reflex action is a motor function. It involves muscle contraction. It is not a voluntary motor activity, rather it is an involuntary one. Reflex is an involuntary motor activity. That means the signals are involuntarily generated. The motor signals that are responsible for reflex motor function are not voluntarily generated by our brain, they are involuntarily automatically generated. And the generation of the motor signal for reflex activity is a sensory stimulus. A sensory stimulus is required to produce the motor signal for reflex action. So the sensory stimuli arise from the peripheral receptors of our body. A reflex action is an involuntary motor response to a sensory stimulus. Being involuntary, we cannot voluntarily control it. Even if we try, it is very difficult to stop a reflex action. Okay, example দেই, যদি আমাদের রেসপিরেটরি ট্র্যাক্টে কোনো ফরেন অবজেক্ট ঢুকে যায়, say a peck of dust or a small insect, for example, a mosquito. If a foreign object, foreign substance gains access into our respiratory passages, for example, in the nose, then after the foreign object comes in contact with receptors in the lining surface of the nasal mucosa, they generate a motor response, which is sneezing. Sneezing is a very difficult activity to suppress. Sneezing, the action, the activity of sneezing is very, very, very difficult to suppress voluntarily. Automatically হয়ে যায়। Upper respiratory passage, lower respiratory passage, for example, in the larynx or trachea. If any foreign object enters these upper airways, then there will be generated a cough reflex. Cough reflexes are also very difficult to suppress. So, see, অথবা অন্যভাবে যদি আমরা বডির ইন্টারনাল কোনো অর্গানে দেখি, if the urinary bladder becomes full with urine, the stretch receptors in the posterior urethra are stimulated. Their stimulation results in what is known as the micturition reflex. And we all know how difficult it is to suppress micturition reflex. So reflexes are involuntary motor responses to sensory stimuli. Now, a reflex activity requires a definite path. And this pathway, the path or pathway for reflex action is known as a reflex arc. A complete pathway of a reflex action is called a reflex arc. The components of a reflex arc are there are two components, or rather, actually, there are five components. These five components can be divided into three groups. The first one is the efferent loop, which consists of number one, the receptor itself, number two, afferent sensory nerve fibers. The receptors may be mechanoreceptors, they may be they may be chemoreceptors, they may be nociceptors, or electromagnetic, or other types. So there are receptors involved. The first component is the receptor. Receptors we know are receptors we know are they are the biological transducers that convert one form of energy into another. In our body, almost all other forms of energy are converted into electrical signals, electrical action potentials. These signals are transmitted via afferent or sensory nerve fibers from the periphery towards the central nervous system, either to the brain or to the brainstem or to the spinal cord. Okay. So the afferent limb consists of receptor number one, number two, afferent or sensory nerve fibers. Then the third component is the center. By the word center, we actually mean the central nervous system, where the sensory signal is read, is translated, is interpreted, and finally processed. The center consists of the brain stem, and the spinal cord. Then we have the afferent in the central nervous system, in the brain or spinal cord. There occurs generation of motor signals in response to the sensory signal. The motor signal is then transmitted via the efferent loop, which in turn consists of first the motor nerve fibers, the efferent motor nerve fibers that carry the motor signal from the center to the peripheral parts. Finally, we have the effector organ that carries out the reflex action. This organ, in most cases, is skeletal or smooth muscle, but sometimes they are glandular structures. Okay. So we have five components in a reflex action. These are the receptor, afferent nerve fiber, integration center in the central nervous system, efferent or motor nerve fiber, and effector organ, which may be a muscle or which may be a gland. In abdominal details, alucinogenic receptor is a special structure that initiates an electrical impulse or sensory impulse where it is stimulated by changes in its surrounding environment, for example, special sensory muscles, etc. Afferent or sensory nerve fibers transmit sensory impulses from the receptor to the integrating center in the central nervous system. The center or integrating center consists of more neurons that convert the sensory impulse into a motor impulse, and they are always located in the central nervous system. The efferent or motor nerve fibers are the nerve fibers that transmits the motor impulse from the center to the effector organ. The effector organ is the organ that produces the motor response, and in most cases, these organs are muscles, and occasionally they are glands. When they are muscles, they can be skeletal muscle, they can be smooth muscle. Example of skeletal muscles are withdrawal reflexes. Whenever we come in contact with a sharp or harmful object, What we do, we move the part of our body that comes in contact with that object. And this involves activity of skeletal muscles. Then there are smooth muscles involved in reflexes, such as defecation reflex or micturition reflex, cough reflex. So there are uh, both skeletal muscles and smooth, and sometimes there are glands involved. For example, salivatory reflex. Salivatory reflex. When a person ingests something, takes some foodstuffs in his oral cavity, there occurs secretion and release of saliva in the oral cavity by the glands. So this is another form of reflex. The glands are um, where the effector organs are the glands. Okay. Now, reflex arc can be classified into monosynaptic reflex arc or polysynaptic reflex arc. In monosynaptic reflex arc, there is only a single synapse between the sensory neuron and the motor neuron. The sensory neuron directly synapses with the motor neuron. And in polysynaptic reflex arc, the sensory and motor neurons do not synapse with each other, rather they communicate with each other via one or more interneurons. If there is one interneuron between the sensory and motor neuron, then we have two synapses. The first one between the sensory neuron and the interneuron, the second one between the interneuron and the motor neuron. There may be more than one interneurons intervening between the sensory and motor neurons. Okay. So in such cases, the reflex arc is called polysynaptic reflex arc, where there are multiple synapses between the efferent and the efferent limbs. Then we have classification of reflex. Reflexes may be classified in many different ways. One of the ways is whether reflexes are present at the time, present or absent at the time of birth. If reflex activities are present at the time of birth, they are called inborn reflexes or unconditioned reflexes. Inborn reflex is a reflex which is present since birth. It does not require any training. Acquired reflexes are also known as conditioned reflexes or learned reflexes. Acquired reflexes are also conditioned or learned reflexes. They are not present at the time of birth. A baby is not born with these reflexes. Rather, he or she develops these reflexes as he or she grows up. One example would be secretion of saliva on the sight, smell, or even thought of food. These are acquired or conditioned reflexes. Then we can classify reflexes clinically. Clinically means when patients come to us to visit a physician, the physician first needs to take a history of the patient, history of the disease of the patient. Then he needs to clinically examine the patient. The physician needs to clinically examine the patient. During clinical examination, there is a part called neurological examination. During clinical examination, we examine all the systems of our body. We examine the musculoskeletal system, we examine the respiratory system, the cardiovascular system, we examine the nervous system, etc. And examining these systems involves elicitation of reflexes. This is part of the new nervous system examination. So when eliciting reflexes, there are different types of reflexes involved, which are due to different sets of receptors stimulated. Now, There are some in some reflexes, the receptors are located superficially in the skin or in the subcutaneous tissues or the mucous membrane. These reflexes are called superficial reflex. In some cases, in some types of reflexes, the receptors are located in deeper tissues of the body, for example, in the muscles or tendons or joints. In most cases, they're located in the tendons, which is why they're called tendon reflexes or deep reflexes. Deep because the tendons are deep to the skin. Those where the receptors are located in the skin are called superficial reflexes. Then we have visceral reflexes, where the receptors are located deeper into the viscera. Superficial reflexes are elicited from the surface of the body. Deep reflexes are elicited in the deeper structures of the body, for example, the tendons. Visceral reflexes are reflexes that arise from the pupils in the eyes and other visceral organs. Visceral organs means GI tract, respiratory tract, urinary tract, etc. Then we have some pathological reflexes. Pathological reflexes are those that occur only in pathological conditions of the body. A normal person who is healthy, physiologically normal, does not exhibit these reflexes. Find it among the clinical reflexes, the first three, the superficial reflexes, deep reflexes, and visceral reflexes, these are all physiological reflexes. They are not pathological. They are present in normal people. Pathological reflexes are only present in patients who have some pathology, some underlying pathology, disease in his body. Okay, now there are examples of these reflexes. Superficial reflexes include cutaneous reflexes and mucous membrane reflexes. Examples of superficial mucous membrane reflexes are corneal and conjunctival reflexes, as well as sneezing reflex. Also, cuff reflex. Corneal reflex occurs when the cornea is irritated and the response is blinking of the eyelids. Conjunctival reflex occurs when, similar to corneal reflex, that when they are irritated and all the response is the same. Sneezing reflex occurs due to irritation of nasal mucosa. The response is sneezing. Examples of superficial cutaneous reflexes. Cutaneous reflexes are those where the receptors are located in the skin and subcutaneous tissues. These include plantar reflex, upper and lower abdominal reflexes, cremasteric reflex, and arm reflex. Plantar reflex occurs when the sole of the foot is scratched or stroked. The normal response is plantar flexion and adduction of the toes. In upper and lower abdominal reflexes, it is the skin of the abdomen that is scratched. It results in contraction of the abdominal muscles on the side of the body where the scratch was given, and it results in movement of the umbilicus towards the side of, toward the direction of the scratch, side of the scratch. So these are called abdominal reflexes. We have premenstrual reflex that results in contraction of the dartos muscle and elevation of the testicles. The skin of the or inner aspect of the thigh is scratched. These are some examples of superficial cutaneous reflexes. Then we have deep reflexes, which are also known as tendon reflexes. Here, the receptors are located in the tendons, which are deep structures that are deep to the skin. And these include jaw jerk, biceps jerk, triceps jerk, knee jerk, and so on. In each case, the receptor is A Golgi tendon organ. The receptor is the receptor is in most cases the muscle spindles, not Golgi tendon. The receptors are muscle spindles, and the effector organ, the muscles. In case of biceps jerk, the tendon of the biceps is tapped, and what happens is in response is the forearm is flexed. The response is flexion of the forearm. This is an involuntary response. This is a flexion of the forearm response to tapping the biceps tendon. It is an involuntary response. It cannot be controlled voluntarily. Therefore, it is reflex action. Similarly, in case of biceps tendon is tapped and forearm is extended in response. Knee jerk, the most common example, the patellar ligament is tapped and it results in extension of the leg and the knee joint. Okay. So these are all reflexes. Then we have visceral reflexes. The visceral reflexes are those where the receptors are located in the visceral organs, internal organs of the body. There are many visceral reflexes. Light reflex is a visceral reflex, accommodation reflex is a visceral reflex. Nutrition reflex is a visceral reflex. Defecation reflex is a visceral reflex. Gastrocolic reflex or colono-ileal reflex. Ileocolic reflex. All these reflexes are visceral reflexes. Okay. Then we have pathological reflexes. Pathological reflexes are those that are not, as I said earlier, not present in normal people. They occur only when some areas of our body are pathologically stimulated. One example is the Babinski sign, which occurs when the outer margin of the sole of the foot is scratched. The normal response should have been plantar flexion and adduction of the toes, but in case of Babinski sign, instead of undergoing plantar flexion, the toes rather go through dorsiflexion. The great toe is dorsiflexed. The other toes are to some degree dorsiflexed, and the toes fan out. It's fanning out of the toes. This is not a normal response, rather a pathological response. It is called Babinski sign. Now, so far we have classified reflexes on the basis of whether it was present at the time of birth or not, number one, clinically. There is another mode of classifying reflexes, and this classification is called anatomical reflex, anatomical classification of reflex. And this depends on the location of the center of integration. Now, here the reflexes are classified as cortical reflexes, cerebellar reflexes, midbrain reflexes, bulbar and medullary reflexes, spinal reflexes. And by the name, we can understand where the integration is taking place. In case of spinal reflexes, the sensory signals reach the spinal cord via the sensory or efferent fibers. They're integrated in the spinal cord. Motor signals are generated in the motor neurons located in the spinal cord, and then the response, the motor signal is transmitted down to the effector organ. Okay. In case of cortical reflexes, the sensory signals reach the sensory cortices of the brain via the corticospinal pathways. Sorry, via the ascending pathways, not the corticospinal, via the ascending pathways. On reaching the motor cortex of the brain, sorry, sensory cortex of Nikhil Panjian, what are you trying to do? So in case of cortical reflexes, the sensory signals reach the sensory areas of the brain, and from there the signals are relayed to the motor areas of the brain, and motor signals are generated there. They're called cortical reflexes. So in case of cerebellar reflexes, the reflexes are integrated in the neural neural connections in the cerebellar cortex, as well as the deep cerebellar nuclei. Okay, so depending on the location of site of integration, uh, reflexes are classified in this way. This is called anatomical classification. So this is about reflexes. Then let's move on to the motor system. Running out of time. The topics in the motor system. We have already discussed reflex activity, except for the properties of reflex. Okay. Among reflexes, there is a type of reflex called withdrawal reflex. Withdrawal reflexes are polysynaptic reflexes, and it involves painful stimuli. When a part of the body, say the hand or the foot, it comes in contact with a sharp or harmful substance or object, what happens is that pain receptors or other types of mechanoreceptors in the skin become stimulated. What they do is they generate signals, receptor potentials, which are converted into action potentials and then travel via the sensory fibers to the spinal cord or the brain. This results in uh, generation of motor signals that cause contraction of muscles, not only contraction, but also inhibition of other sets of muscles that allow the person to withdraw that affected part from the harmful or injurious substance. These are always polysynaptic reflexes. And this is the pathway for withdrawal reflex. Uh, Now, come on. Now, properties of reflexes. The properties are delay, summation, irradiation, recruitment after discharge of motion and subliminal fringe, fatigue, fractionation, reciprocal innervation, and prostate sensor response. I will not discuss all of them, but only a few. Delay in reflex is the short interval between the stimulus and the reflex response. This delay in most cases occur due to the time taken for the signals to travel from the from the receptor to the center and from the center to the effector organ. Number one. Number two, it also depends upon the time taken for the neurotransmitters to be secreted and cross the synaptic spaces, and finally bind with the neural receptors in the postsynaptic membrane. So this is synaptic. This is a delay in reflex. It is somewhat similar to synaptic delay. Summation, special methods যাচ্ছি না irradiation, after discharge, fatigue, reciprocal innervation একটু discuss করি. Reciprocal innervations occur when afferent impulses, sense, sensory impulses, pass via the dorsal root into the spinal cord, stimulates motor response, stimulates motor neurons that supply the flexors. They not only supply the flexor muscles, but the flexor muscles of a joint, but they also inhibit uh, the extensor muscles of on the opposite side of the joint. This is done by stimulation of the motor neurons that supply the flexor muscles and inhibition of the motor neurons that supply the extensor muscles. This opposite activation and inhibition of one set of muscle and inhibition of another set of muscle that has the opposite activity is what is called reciprocal innervation. এরপরে আরেকটা হচ্ছে crossed extensor response. Crossed extensor response occurs. This is most apparent in midbrain reflexes. Crossed extensor response occurs when the one limb is moving in one way, another limb is moving in the opposite direction. For example, if during a reflex the flexor muscles of, say, for example, the right arm are stimulated, the flexor muscles of the left arm will be inhibited. And the extensor muscles of the left arm will be stimulated. This is what is called crossed extensor response. If flexor muscles of one limb are stimulated, the extensor muscles of the opposite limb will be stimulated. This is what is known as crossed extensor response. That means when we are withdrawing one limb from an harmful or injurious stimulus, the other limb is extended. এগুলোতে যাব না, muscle spindle. Muscle spindle is a complex organ. Muscle spindles are actually they are receptors. They are mechanoreceptors. Muscle spindles are mechanoreceptors that are involved in maintenance of muscle tone of skeletal muscles. Now, sensory organs that encapsulate a spindle form and spiral form shape, they're located in the most fleshy portion of a muscle, the belly of a muscle. They're made up of intrinsic not intrinsic, intrafusal rather. Muscle spindles are made up of intrafusal muscle fibers. A skeletal muscle is composed of mainly two types of muscle fibers. Number one is extrafusal muscle fibers, which make up the bulk of the muscle. The other one is intrafusal fibers. Extrafusal fibers, in most cases, they span the whole length of the muscle. Not all of them, but most of them. But intrafusal fibers, they're very short. They do not span the whole length of the muscle. Rather, they remain because their lengths, because they are much shorter than the extrafusal fibers. They cannot span the muscle. They remain in the most fleshy portion of the muscle, deep in the fleshy portion, and they are innervated. They're innervated by different types of nerve fibers, both motor and sensory. There are gamma motor neurons innervating the muscle spindles. intrafacial fibers of the muscle spindles. There are alpha motor neurons. There are sensory neurons, type 1, type 2 sensory nerve fibers arising from the muscle spindles, from the intrafacial fibers of the muscle fibers. The function of the muscle spindle is that they are involved in reflex connections that constitute the feedback device that help maintain the muscle length. And in this way, it also helps maintain the muscle tone. The term muscle tone refers to the fact that when in the resting state, a muscle is not muscle is not fully relaxed, neither it is fully contracted. It is at a state somewhere in between. This in between state is called muscle tone. Here, what happens is the muscle fibers are in a partially contracted state. The muscle fibers are in a partially contracted state, and this partial state of contraction is what is called muscle tone. And muscle tone is maintained by muscle spindles.